Alright guys, so we'll pick up where we left off yesterday in class. So in this problem, we're given two bits of information about the fountain and its design. So the horizontal distance that the water will travel is given by this equation, and the maximum height that the water will travel is given by this equation. And these equations come from physics. They describe the parabolic motion of objects under the influence of gravity. Now, the equations as they're given separately are not as easy to work with for the purpose in this problem. So if we put them together, we might be able to simplify them and have an easier time answering question B. So we're going to start with that. We're going to take the two expressions for the height and the distance and see if we can simplify them. So we're going to have height divided by distance. So we've got some stuff that's going to cancel out here. Let's get rid of the compound fraction first so it's easier to see what's going on. So we're going to have these v squareds are going to cancel out. And this bottom fraction here, we can flip over and divide by it, or multiply by its reciprocal. So let's go ahead and do that. So v squared Alright, so now it's a little bit easier to see what's going on. So these v squareds are going to cancel out. G's are going to cancel out. And we'll just be left with okay. So we can still simplify this by using the new identities that we learned yesterday. Now, we could try to convert sine squared theta, or another thing that we could try to do is we could try to convert sine 2 theta. So before we decide what to do, we should look at the identities and see if we can spot how one of them might help us simplify it. Now, we do have a lot of identities that involve sine squared theta, but they look like they might make it more complicated, potentially. We'll be adding basically two different terms in both cases. So maybe that's not the way to go. Our other term that we were looking at was sine 2 theta, and it includes a sine and a cosine. But this might be a good idea because if we look back in our numerator was sine squared theta, so that sine could cancel out, and then we can use a reciprocal identity. So we'll go ahead and do that. So the top we're going to leave alone. And then on the bottom we'll have 2 times, and then the identity that we were looking at here was that sine 2 theta was equal to 2 sine theta cosine theta. And so we can cancel this out, and this one, just one of them, and we'll get sine over cosine and 4. So this does simplify down quite a bit to tangent theta over 4. So that's going to be a lot easier to use for part B than the original function was. And they asked us in part B to find that ratio of the height over the distance when the angle of elevation was 27 degrees. So we'll put that in. And then we'll evaluate using our calculator. We'll just make sure that we're in degrees. There we go. And there we go. And if we wanted to round, they round to the hundredths place in the book, so we could do 0.13 if we wanted. There we go.